Welcome everyone to our lecture on the topic of laws of motion. So in this lecture we will be uh, talking about how to do general questions in this chapter. Uh, so we will be picking up the concepts which we talked about in the last video, that were the ideas of normal forces, how normal forces act on a body, how tension force acts on a body, uh, why tension force is same across a rope when the rope is massless, and so on. So all these ideas are used in solving the questions. So let us move ahead and let us discuss how we are going to solve it. So first step in solving any question in this chapter begins with deciding the system. By the phrase which means deciding the system, we mean to say that uh, whether we are studying a block, let's say we are going to study a block, then we'll be concentrating only on the forces acting on the block. And this is what is meant by this particular statement, that only the forces which are acting on the system will be considered in that particular diagram or in that particular case. What the system or what the block or the rope or pulley exerts a force on some other else does not matter for now. What matters is what are the forces acting on what we have decided to study, and that helps us in simplifying the problem, and that is why this is the first step in doing the any question. Next, we'll be writing the list of all the forces acting on the system. So that means if we have decided a block, then what is the gravitational force on the block? What is the force exerted by tension force on the block? What is the force exerted by the normal force on the block? All these forces have to be listed one by one until we have sufficient practice that we can simply draw the block or draw the pulley and write the forces in the diagram itself. So it is really a good practice to make a list in your head of all the forces acting on it. And this basically works in complex problems when there are more than four forces, five forces acting on the block. Then it gets really hard to determine all the forces acting with all the directions and their magnitudes. Third step in solving a question is going to be making a free body diagram. What is a in a free body diagram? We mean that when a body is drawn, we will be separating that body uh, the from the neighborhood of all the uh, ropes, surfaces, and pulleys in the neighborhood of the block. We'll be separating the block from all the neighborhood, what you can say, objects, and after separating the block, we'll be drawing all the forces which are exerted by the said pulley, surface, or the rope on the block in the new diagram. So that is what we meant by free body diagram, by separating the body and drawing it new uh, in a new fashion, so as to only study the forces acting on the body rather than studying what is going to uh, be the forces exerted by the body. And the last point which we are going to do is we are going to choose an axis and write equations. So we'll be learning about this point as we move along. Usually we are going to choose the axis in which acceleration is occurring. There will be one axis along which the acceleration would be occurring, one axis along which there will be no acceleration usually. And when that happens, we write the equations along the direction in which acceleration is happening and along the direction in which acceleration is not happening. Besides that, other situations can also occur, as we will see, when there are accelerations in both x and y directions or multiple directions. So in that case, we have no other option but to write equations in both the axes. Okay, so let us jump on and jump on to the questions. So the first question which we have is that of a uniform sphere. So there is a uniform sphere of weight W and radius 5 centimeter. So radius of the sphere is 5 centimeter. It is tied to the wall by a string like this. And this is the wall which we have selected, and this is the sphere. So this is the string which we are talking about. A string is massless and inextensible, thin string. The sphere, the weight of the sphere is W. So weight of the sphere is W, and we can directly draw it. That is the weight of the sphere. It is being held by a string like this, like that. It is being drawn. The radius of the sphere is 5, and this distance is given to us as 8 centimeter. The tension in the string will be dash. So this particular distance is given to us as 5. This distance is 8, and this complete distance would then become 13. So we can draw it as 13. So we are supposed to find the tension in the string. So the tension in the string, that is what we are supposed to find. So how would the tension forces act in the string, as we can see? So we know that tension force acts along the string because it can act only along the particles of the string, and the string is tight in this direction. So that's why in all the cases from now on, it should be a general rule for us that tension only acts along the string. So you have a sphere and you have force acting on it in this direction. So this force, we have said this force is tension. Let's say we know some knowledge about the angle at which tension is acting. Let's say this angle is theta, then this would become this angle, which is theta. And since this distance is 13 and this particular distance is 5, from Pythagoras theorem we can find easily that this distance would be 12. So this angle is theta, this angle is 90. The weight force is acting in vertically downward direction. So let us just draw the weight force. W is the weight force. It is acting in downward direction. And what would be the normal force? So the normal force acting on this sphere would be perpendicular to the flat surface, as we have discussed. So this is the flat surface in this particular case. This is a flat surface, and normal force would act perpendicular to it. So it would act perpendicular to the wall, and it would act on the ball or the sphere to the right, towards the rightward direction. As the sphere is trying to push the ball towards left direction, it wants to make the string vertical. It is pushing the sphere in leftward direction, and the reaction of that force acts on the sphere towards the right. So this is the direction of the normal force acting on the sphere. So the second diagram, we can say this is this is the free body diagram of the sphere. So like we said, what we discussed, that how to approach such a question. First we select the system. So selecting the system in this case was pretty easy. That was the sphere, and by selecting it, what we did was we only thought about the forces acting on the sphere. So we started listing the forces on the sphere. That was step number 2. So the forces on the sphere were weight, the tension force, which we did an investigation that at what angle the tension was acting, and the normal force acting on the sphere. So these were the list of the forces. Then we draw the free wall diagram, and next we are going to choose the axis. So the axis in this particular case are going to be pretty easy to choose. We are going to choose the x and y axis. So the sum of forces in x-axis should be equal to mass times acceleration in x-axis, and similarly the sum of force in y-axis should be equal to mass times acceleration in y-axis. Since both these accelerations are zero as the block is in equilibrium, by equilibrium we mean that the net force acting on the particular body which we have selected is zero. That is what we mean by equilibrium. So if we are to write the forces acting on the block in x direction, simply the normal forces acting in x direction, and the component of tension would act in x direction. So to take the component of tension, we are going to resolve tension in two directions. So the component of tension along the direction, along the side in which theta is acting would give you cos theta. That means this side would be t cos theta, and the component of tension perpendicular to the side to the theta in front of theta would be t sin theta. So that means tension t cos theta is acting in negative x direction, so we will take minus t cos theta, and that would be equal to 0. And similarly, let's say t sin theta, it is acting in positive y direction, upward direction, and the weight is acting downwards. Then we'll take a negative sign with that. So from this we can easily figure out what is the tension in the string. The tension in the string would be equal to tension is equal to weight of the string divided by sine theta. So sine theta from our diagram would be simply 12 upon 13, since it is perpendicular upon hypotenuse. Perpendicular of a right hand triangle is 12. So this gives us the tension in the string as 13 times W by 12. So that would be the tension in the string. Next question. The acceleration of a lift which operates near the surface of Earth is A equal to 0.2 I cap and 0.2 J cap meter per second square. Find the force exerted by the lift on the 2 kg block kept on the floor of the lift as shown. So there is a lift which is accelerating in a two-dimensional way, and we have to find what is the force exerted by the lift on the 2 kg block. So how do we do it? So let us draw this diagram to visualize what is happening. So we have drawn the block. The block is of mass 2 kg, and there is an acceleration A. So the acceleration is equal to 0.2 I cap plus 0.2 J cap meter per second square. So this is the acceleration which we are given to. In addition, we know the action due to gravity 9.8 meter per second square. So we know that the whole elevator is moving with this acceleration. That means the block would also be moving with this acceleration, right? So that is what we know. So if we imagine how it will be possible, so for that to be possible, normal reaction on the block would be acting in two directions. That is the x direction and the y direction. And so we have completed step number 2. We have listed all the forces acting on the block. Now we'll choose the axis. So let us say this is the x-axis and this is the y-axis, and we know the acceleration of the system. Uh, it is given to us. Okay, so let us write the Newton's second laws. Let us write the equations. So for all the questions which we are going to do um, in this particular topic, we are going to write the equations and we are going to write the same equations again and again. That is the summation. That is the sum of all forces in x direction is equal to max, and sum of forces in y direction is equal to may. Here writing the sum sign helps us in reminding us that we have to take the sum of all forces in x direction, and if not, take the component of forces in x direction like we took in the last case. So this would be doing in this case also, and all the questions from here on. So we know the mass of the block. Mass of the block is 2 kg, and let us start writing these equations. So the sum of forces in x direction, the only force in x direction is nx. So nx is equal to mass of the lift, the mass of the lift, or mass of the block. Mass of the block is 2 kg, and the acceleration in x direction. So the acceleration of the block in x direction is 0.2 meter per second square. So 0.2 meter per second square, that is the acceleration in x direction. The component, the coefficient of I cap is the acceleration in x direction, and the coefficient, the thing besides j cap, is the acceleration in y direction. So this gives us 0.4 newtons. So the normal force acting on the block would be this. Similarly, the normal force acting on the block in y direction, or writing this equation, that is sum of force in y direction. So plus ny, since ny is in upward direction, and downward force, that is the weight of the block, is equal to mass times acceleration may. Weight of the block, we know it can be written as 2 into 9.8 meter per second square, and 2 into acceleration in y direction is 0.2. So that would give us normal reaction by direction is of 0.4 newtons plus 19.6 newtons. So that would be a total of 20 newtons. So the force exerted by the lift on the 2 kg block would be in such a way that it would try to push the block in x direction and also hold its weight and provide some acceleration by direction also. So that's why the both the sides of the block, that is the bottom side and the left side of the block, are experiencing some normal forces, because of which they are able to get some acceleration. So the normal force vector acting on the block, we can write it as 0.4 I cap, because 0.4 newtons force is in x direction, and 20 j cap newtons. So with this particular question, um, what we have learned up till now, let us try to recall that. So what we have learned up till now is that whenever we are going to approach the questions in this particular chapter, we'll try to focus on these 4 points while doing the questions. That is to, number 1, decide the system. That is what are the forces acting on the system. We are only going to think about that. Second, we are going to list all the forces when there is a case that there are a lot of forces acting on the system. Then make a list of the forces. Third, make a free body diagram, that is isolate the body uh, from all the environmental quantities in its vicinity. And fourth, we'll choose an axis and we have to write the equations. So the equations always remain the same, but the only thing which changes is the choosing the axis. So with this, we will be concluding this video, and thank you for joining. In the next video, we'll be continuing with more questions and examples, and we'll be doing much more questions. So thank you and have a nice day.